This rock may look completely worthless, but hidden inside it is one of the most valuable materials on Earth: gold. But before gold becomes jewelry, coins, luxury watches, or billion-dollar reserves locked inside bank vaults, it begins its journey as ordinary rock buried deep underground. And extracting it is one of the most difficult industrial processes on Earth. Most people imagine gold mining as miners finding shiny nuggets hidden in rivers or caves. And while that does occasionally happen, modern gold production looks completely different. Today, gold is usually trapped inside enormous deposits of rock containing only microscopic traces of the metal. In many cases, the gold particles are so small they can't even be seen with the naked eye. And reaching those tiny traces requires machines, chemicals, heat, and engineering on a massive scale. To find gold deposits, mining companies spend years studying the land using geological surveys, satellite mapping, drilling operations, and rock analysis. Teams of geologists examine underground formations searching for signs that gold may exist beneath the surface. And once a profitable deposit is confirmed, the real operation begins. Entire sections of land are cleared to create access roads, processing facilities, pipelines, power systems, and massive mining zones. Some gold mines eventually become so large they can literally be seen from space. In open-pit mines, workers remove layer after layer of earth using controlled explosions powerful enough to fracture entire sections of rock. After each blast, giant excavators move in to load the broken material into enormous haul trucks. These machines are almost unbelievable in size. Some mining trucks stand several stories tall and carry hundreds of tons of rock in a single trip. Their tires alone can weigh more than an average car. And the operation never really stops. Day and night, machines continue digging, transporting, crushing, and processing material non-stop. Entire industrial systems work continuously because every hour of shutdown can cost enormous amounts of money. But despite all this effort, gold remains incredibly rare. In some mining operations, workers process an entire ton of rock just to recover a few grams of gold. That means mountains of earth may be destroyed for an amount of metal small enough to fit in your hand. That rarity is one of the main reasons gold became so valuable throughout human history. Once the ore is removed from the mine, it's transported to a processing plant where the transformation truly begins. And the first step is destruction. Massive industrial crushers use heavy steel mechanisms to break giant rocks into smaller fragments. Conveyor belts move the material deeper into the facility while clouds of dust fill the air. But the rock still isn't small enough, because the gold remains trapped inside the surrounding minerals. So, the crushed ore enters giant grinding mills. These rotating machines are partially filled with heavy steel balls that continuously tumble and collide with the ore inside. As the mill rotates, the steel balls pulverize the rock over and over again until it becomes an extremely fine powder. The goal is simple. The smaller the particles become, the easier it is to expose the microscopic gold hidden inside. And some facilities process thousands of tons of ore every single day. The grinding systems run continuously, sometimes for years at a time. By this stage, the original rock is completely unrecognizable. What once looked like solid stone has now become a grey powder mixed with water into a thick slurry. And this is where the process enters its most dangerous phase. The slurry is pumped into enormous industrial tanks where workers add cyanide, one of the most toxic chemicals used in modern mining. Cyanide has a terrifying reputation, and for good reason. In large enough quantities, it can be deadly to humans and devastating to the environment. But despite the risks, cyanide remains one of the most effective substances ever discovered for extracting gold, because, chemically, it does something extraordinary. It bonds directly with gold at the molecular level. When cyanide mixes with the powdered ore under carefully controlled conditions, microscopic particles of gold slowly dissolve into the liquid solution. The surrounding rock remains behind as waste material, while the gold moves invisibly into the chemistry. It's a process known as leaching, and without it, recovering microscopic gold from low-grade ore would be almost impossible on a large industrial scale. But this stage also creates enormous responsibility. If cyanide leaks into rivers, lakes, or groundwater systems, the environmental damage can be severe. That's why modern mining facilities are built with strict containment systems, monitoring equipment, emergency response procedures, and carefully controlled chemical handling. Workers wear protective equipment. Tanks are constantly inspected. Pipelines are monitored around the clock. Because while the process is highly effective, it can also become extremely dangerous if mishandled. After hours, sometimes days, inside the tanks, most of the gold has now dissolved into the liquid solution. But even at this stage, it still doesn't look valuable. There are no glowing gold bars yet. No shiny metal. Just dark liquid, wet residue, and industrial machinery. The gold remains hidden inside the process. To recover it, the solution passes through special systems containing activated carbon. The dissolved gold sticks to the carbon surfaces, while the remaining liquid continues through the plant. Then additional chemical reactions separate the gold from the carbon itself, creating a concentrated material that contains gold along with small amounts of other metals and impurities. This concentrated material is filtered, dried, and prepared for the next stage. And this is where the transformation finally becomes visible. Smelting. Industrial furnaces heat beyond 1000 degrees Celsius. The concentrated material is loaded into the furnace along with special compounds called fluxes, which help separate unwanted substances from the molten metal. Inside the extreme heat, the material begins to melt. The furnace glows bright orange. Heat waves ripple through the air, and slowly, liquid metal starts to form. As the molten mixture settles, impurities rise to the surface as slag, a layer of waste material removed by workers during the process. What remains beneath it is far more valuable. Molten gold. Bright. Glowing. Liquid metal heated to extreme temperatures. For the first time in the entire operation, it finally looks like the gold people imagine. But even after smelting, the metal may still contain traces of silver, copper, or other elements. So the gold undergoes additional refining processes designed to increase its purity even further. Some facilities use electrochemical refining methods. Others rely on advanced chemical purification systems. The goal is always the same: to remove the final traces of contamination until the gold reaches extraordinary levels of purity, 99.99% pure. At this stage, the molten gold is ready to become bars. Workers carefully pour the glowing liquid metal into molds. At first, the bars shine bright orange from the heat, but as they cool, the surface hardens into solid gold, dense, heavy, and incredibly valuable. What began as dull rock buried deep underground has now become one of the world's most desired materials. But gold is far more than a symbol of wealth. Modern civilization depends on it in ways most people never realize. Gold is used inside smartphones, computers, medical devices, satellites, aerospace systems, and advanced electronics. Because gold conducts electricity extremely efficiently, while also resisting corrosion and chemical decay. Unlike many metals, gold can remain stable for decades without rusting or degrading. That combination of conductivity and durability makes it incredibly useful in high-precision technology. And even today, many central banks continue storing massive quantities of gold as part of their financial reserves. Because throughout history, gold earned a reputation as something stable, something people trust. From giant open-pit mines, to crushing systems, to toxic chemical extraction, to blazing furnaces hotter than lava. This is the reality behind gold production. A process involving enormous machines, dangerous chemistry, extreme heat, and non-stop industrial operations. All to recover one of the rarest and most valuable metals on Earth. And most people never get to see it. This is Made in Reality, where we uncover the truth behind how the world is made. Subscribe, and we'll see you in the next one.